Vector kinematics. Last session, we discussed the vector kinematics, and we stated that we discussed these two equations. R is the position vector at any time. It is equal to R naught, the position vector at time equal to 0 plus the vector velocity multiplied by time. And also we stated that v at any time, the vector equals to initial velocity plus the vector of acceleration multiplied by t. And also we show that v, the velocity vector, is equal to the derivative of the position vector with respect to time. So today we will have another example based on this equation, the vector kinematics. This is a treatment of the kinematics using vectors. So we will have another example. The example is, you see, at time t seconds where t larger than 0, a particle p moves such that its velocity v is given by v equals 2 minus 6 squared t, 6t squared, and this I multiplied by I is the unit vector in x direction, minus t j is the unit vector in the y direction. When t is the displacement of the particle from a fixed origin O, at t1 the displacement of the particle from fixed origin O is 5I. Find the distance of the particle from O when t equals to 5. Solution. Okay, now we have just showed that v is equal to, you see, it's equal to 2 minus t minus 6t squared I minus tj. I put this hat above the unit vector to show that it is a unit vector. Here in the book, it is typed as bold, but when handwriting, we put the vector with a hat like this. So now that means this one, v, the vector v, and at the same time equals to dr by dt. Now r, how can I find r from this equation? Of course, it is by integration. So it is 2 minus 6t squared plus tj. So this one is minus tj, and it is dt. So I can integrate this one. You see, this, to integrate this part, it will be 2t minus 2t cube multiplied by I minus half t squared j plus some constant vector, I call it c. So this one, c, is a constant vector. So this one is not a unit vector, so I have not used the hat, just put an arrow like this. Okay, at t equals 0, r equals 5I. So I'll plug in here, you see, r equals 5i. So now you see, now I'll plug in these values in this equation. I'll plug in r equals 5i and t equal to 0. So substitute these values here. I'll get 5i equals to these. 2t means 2 multiplied by 1. 2 multiplied by 1 minus 2 multiplied minus half t, which is 1 squared plus, from which we can simplify this one. We will find that the vector c will be 5i plus half j. Okay, so now r equals, I'll substitute these values in this equation in the c. So I'll get plus 5i plus half j. Okay, now at t equals 5 seconds, then I'll plug in 5 here in this equation. I substitute, I'll put, instead of any t here, I'll substitute 5 and simplify. This will result in equals to minus 235i minus 12j. Okay, so this is the r. So it is, find the distance of the particle from O. This is the vector from O. This is the vector from O. Now the distance is the length. The distance equal the length of r, or the modulus of the r, and it will equal to minus 235 squared plus minus 12 squared, and this will be equal to 235 meter from the origin. So this is the solution of this question. We will continue to the next example.